All right, we'll get going. Just to let everybody know, this is being recorded. So if you have folks that couldn't make it tonight and are interested, or you know somebody after you see the talk, you really want to share it with them, you can. We will have this recording up after it's trimmed down a bit on our YouTube channel, so you can check it out and any past events that have been done during COVID, because they're all recorded. So hopefully we will get away from the recorded side of things soon. We're hoping to get in January in person, but we will see if we're able to get that going. But stay tuned. All the information will be up on the website sometime soon. I should introduce myself. My name is Jim Gall. I'm the host of the Grit City Think and Drink, and I'm a professor at the University of Washington in Tacoma. Welcome all to the Grit City Think and Drink. This happens the second Tuesday of every month. And we have our schedule getting planned out for 2023, including our next talk. So January 10th is the next one. And Dr. Alex Nutter is going to talk about, this is her title, not mine, do some fucking yoga and get back to work, self-care in the neoliberal workplace. So I love a title that can actually bleep itself out. So hopefully you'll come in January, check that out, and all our other talks in 2023. So just to give you a quick spin down for those of you who haven't been here before, I'm going to introduce our speaker. She's going to give you an amazing talk. We will then take a short break and I will give away some swag, well, sort of virtually, and I'll give you the details of that later on. And then afterwards, there's a chance to ask questions of our speaker and play Stump the Speaker. So we will get going here and I'll introduce our speaker, but be ready to chat any questions or difficulties you're having to me, and I will make sure that I try to deal with them while our speaker is working. So I want to introduce our speaker. Rachael Fricke is a PhD student in the School of Aquatic and Fishery Sciences at the University of Washington, Seattle, where she also completed her BS. Her work broadly seeks to understand human interactions with freshwater and information management strategies, accounting for both ecologic and anthropogenic needs. She is also an avid outdoors person and likes to injure herself while out in the outdoors. Well, maybe not doesn't like to, but she does do that because she's so avid. So without further ado, Rachael, it is all yours, and I'll stop sharing.
Great, thanks, Jim. All right, we good? Can everybody see my screen? I can't see anyone. So Jim, can you see my screen? Yeah. Do this. Good.
Yep, now you're good.
Okay, thanks. So thanks for the intro, Jim, and thanks to everyone who logged on this evening to listen. I'm not drinking a beer because I'm recovering from a cold, but I'll be drinking water today. I'm really excited to talk with you all today about a topic that's taken up a lot of space in my brain for the better part of the last few years, and that is smartphones, outdoor recreation, and how we might leverage the gobs and gobs of data that we generate with these devices to inform natural resource management. So if you enjoy going outside and you live in Western Washington, there's a good chance you've thought about crowds. This is a photo of Rattlesnake Ledge, which can be reached in a short hike accessed via a trailhead along the I-90 corridor near North Bend. Places like this are popular because it's easy to access, offers a beautiful lake view, and is also highly publicized by way of pictures posted to social media. Social media posts related to outdoor recreation at specific locations have led to a phenomena that is often referred to as the Instagram effect, which you might think of as excessive overcrowding. Many are wondering if this is ruining our public lands. But on the flip side, social media is also calling in a new generation of younger, more diverse individuals into recreational activities like hiking, camping, fishing, boating, and biking, and improving the accessibility of the outdoors to populations that have historically been excluded. Understanding and maintaining access to outdoor spaces is critical, both for ensuring the continuation of human health benefits associated with spending time outside, and for maintaining the large economy built around outdoor recreation. Human health benefits from nature include physical wellness through activity and exercise, improved mental health from stress relief, and social connection. Outdoor recreation is also a lucrative economic sector, with consumers spending around $880 billion annually on related gear and travel. Today, I'll be focusing on lake-based recreation, the typical activities we associate with lakes, especially in nation-scale estimates of outdoor recreation, are fishing and boating. But if you look at this picture of Angle Lake near SeaTac Airport, you might immediately notice that there actually aren't a lot of people fishing or boating on this lake, at least not with the large motorboats that we typically associate with boating. Estimating human activity on water bodies is really critical for valuing lake contributions to people and ensuring the continuation of those benefits. As shown in these photos, humans appreciate lakes for a wide variety of different reasons, including swimming, kayaking, or paddleboarding, relaxing on the shoreline, viewing wildlife, and fishing. Understanding when, where, and how we're using lakes can enable strategic allocation of funding and resources to support the most visited lake access points across the landscape. But estimating lake use is a difficult challenge. People travel to lakes through multiple transportation pathways, including driving, public transit, and walking. And lakes are spread out across the landscape in a mishmash of public and private access, with lakeside public parks and boat launches falling under a broad mosaic of different city, county, state, and federal jurisdictions. In terrestrial settings, such as a hiking trailhead, measuring visitation is pretty straightforward. Every individual who visits the trailhead hikes along the same path, and we can install infrared traffic counters, which count every person that passes them. We could realistically do this at boat launches or parking lot entrances, but as I said earlier, this would only estimate one particular type of lake use, or would only get at a fraction of the actual total visitors to a lake. Currently, lake visitation is inferred from sparsely conducted in-person or mail-in surveys, which often are only able to capture human behavior over smaller spatial scales, such as a county-wide survey. Furthermore, these data can exhibit timescale biases because lake users are often only able to accurately report the lakes that they visited most recently, say in the last few weeks or months. In addition, these approaches tend to target specific user groups like boaters or anglers, and they fail to holistically capture the wide array of water-based activities that actually occur on lakes. A news article from a few years ago called "Lots of Fish on the Screen" is actually what initially drew me into thinking about how social media might help us tackle the challenge of trying to estimate lake visitation. Communities centered around specific recreational activities like fishing are highly active across platforms, but also lake users more broadly often post about their experiences on social media too. These examples are from posts uploaded to Twitter and Flickr from lakes in Western Washington State, some of which include Beaver Lake in the upper right-hand corner and Lake Washington in the upper left-hand corner. So when I say social media, you might have a particular app that comes to your mind if you are a social media user, such as Facebook or Twitter or Instagram or TikTok. There are obviously big generational differences in the types and kinds of social media that we use. As a scientist who uses social media data for my research, I think of these as specific social media platforms, with each platform serving a distinct type of user group. Obviously, a lot of us use multiple social media platforms, but each one serves a somewhat distinct purpose in our own minds. For example, Twitter is a social platform that allows users to post texts and images, sharing what's going on in their life, or just random thoughts. Flickr is a photo sharing platform used primarily by both professional and amateur photographers. eBird and iNaturalist are apps that allow users to share their wildlife observations and have their identifications confirmed by other users. And Gaia GPS is an activity tracking platform that lets users measure and time their runs, bike rides, and other types of physical activities. There are some heavy-hitting social media platforms that we don't actually have access to, including Facebook and Instagram. That's because Facebook has chosen not to make their data available to researchers. I'll emphasize here that all of the data we work with is anonymized. We don't receive users' full names, addresses, or any identifying information. There are lots of examples of the use of social media to estimate use of public lands. Previous studies have used Flickr and/or Twitter to estimate visitation at US national parks, global recreational sites, Vermont state parks, and New York City parks. This figure on the left is from a paper by Wood et al. In 2013. On the y-axis is empirical visitation, or the actual on-site visitation at those recreation sites. And on the y-axis is, and on the x-axis is visitation from Flickr posts. As you can see, there's a strong positive correlation in the frequency of visitation, but the actual number of in-person visitation is much larger than the total number of Flickr posts. For the rest of this talk, I'll dive into some of my own work using social media to understand visitation at lakes in Western Washington. Then I'll discuss potential applications of this data beyond simply estimating visitation, focusing on management of aquatic invasive species. Lastly, I'll discuss some of the challenges and opportunities that social media offers in the context of natural resource management. So our first steps in harnessing the power of social media to estimate lake visitation were to compare the ability of different social media platforms to predict on-site visitation. We acquired data from the photo sharing platform Flickr, the species ID apps, eBird and iNaturalist, the social media platform Twitter, and the activity tracking app Gaia to inform our analyses. I want to emphasize that each one of these different data sources represents somewhat distinct lake user groups pursuing particular activities when they might go to lakes. For example, Flickr users who tend to be professional photographers might be appreciating the aesthetic value of lakes. Individuals identifying species via iNaturalist and eBird are both contributing to scientific knowledge and valuing the natural attributes of lakes. Gaia users are tracking their physical activity, and Twitter users might be engaging in a really wide array of activities, including recreation, cultural heritage, and artistic or spiritual endeavors. So for our methods, we started with lots of posts from social media users, each of which has a geolocation or latitude and longitude associated with it. We intersected these posts with lakes and threw out any posts that didn't fall within 50 meters of a lake. This gave us between 2,500 and 7,500 days of user activity per each social media platform. Our on-site visitation data set consists of instantaneous counts of the number of people visiting these 50 different lakes shown in the map in King and Snohomish counties around Seattle and Everett. These counts were collected by volunteers surveying lakes for the counties to collect chemical and physical information about the lake. Volunteers counted the number of people on or in the lake and on the shoreline. Counts were taken a couple of times each month for the years 2015 through 2019 during the peak summer visitation months of May through October. Now to dive into some results. First, here I show social media visitation on the x-axis and on-site visitation on the y-axis. Each plot is one of the social media platforms we incorporated into our model. I left Gaia out for visual clarity, but it's pretty similar to Twitter, iNaturalist, and Flickr. As you can see here, Flickr, iNaturalist, and Twitter observations all show a positive correlation with on-site visitation. And that's exhibited by the high R values you see in the lower bottom right corners of each plot. When R is closer to 1, it means those two data sets are more correlated. And when it's closer to 0, it means there's little to no correlation. So on the other hand, eBird data doesn't really seem to correlate with on-site visitation. And this isn't too surprising given that lake attributes conducive to birding, such as natural riparian areas and really quiet, calm settings, aren't typically associated with urban and suburban lakes that have a lot of public access on them. So here I'm going to show the results of our model testing using different combinations of social media data plus measures of shoreline access and population density to model on-site visitation. On the left, I'll show the social media platforms we used in the model, and on the right, I'll show the delta AIC values, which is a statistical measure of model performance. A delta AIC of 0 is best, and models with a delta AIC below 2 are still considered good. So our best model was Twitter and Gaia with a delta AIC of 0. Our next best model was Flickr, Twitter, and Gaia. Our next best model after that was iNaturalist, Twitter, and Gaia. And then our fourth best model was eBird, Twitter, and Gaia with the delta AIC of 1.42. So as you can see, the common denominator here is Twitter and Gaia. And that's because Twitter and Gaia are very similar data sets to each other. In science, we say that they're co-correlated. And I think that Twitter is kind of largely driving this. If we compare these models to models informed by only one platform, on the right, we see that models of multiple platforms included in them perform roughly 3 times better. So even though Twitter by itself is still a pretty predictive data set, across the board, models are better when we work with multiple sets of social media data from different platforms. So now that we've walked through using social media data to model visitation, I'd like to discuss one of the cool potential applications of this data, which is informing the management of aquatic invasive species. So people love recreational fishing. Anglers invest a lot of time and money into their sport. And this dedication drives really frequent movement between lakes in the hopes of just getting a bite or catching a particular type of fish. Angler movement contributes to the invasion process by introducing species to new environments and by promoting their spread into additional lakes in a region. The type of species moved is often dependent on the gear that anglers are using when they are going fishing on a lake. So bait buckets hold live fish, which are often released into water bodies at the completion of a trip. Fishing lines can entangle zooplankton. Aquatic invasive plants are frequently moved on boat motors and trailers. And stationary animals like mussels can encrust on boat hulls. Examples of invasive species which are prevalent throughout the United States and commonly moved around by angling activities include spiny water flea, zebra and quagga mussels, parrot feather, Eurasian milfoil, fathead minnow, and rusty crayfish. Spiny water flea eat native zooplankton species that are critical food for native fish. Zebra mussels can clog water intake pipes that power plants. Parrot feather and milfoil can become entangled in boat motors and even drown swimmers on occasion. Fathead minnow can outcompete native fish for food, and rusty crayfish eat fish eggs, destroy habitat, and displace native crayfish populations. So with the goal of informing invasive species management, for this study, we asked if we could use social media to trace angler movement over broad spatiotemporal scales. To do so, we worked with a really cool data set from a smart fishing device and linked smartphone application called iBobber. iBobber is a sonar-enabled fishing bobber made by Real Sonar, which pings its location every 50 seconds, giving us fine-scale data on when and where anglers are fishing. Some anglers might only use it a few times during a trip to get a depth reading, while others will use it continuously while they're fishing. There are currently more than 60,000 units operating globally, with an average of 1,100 daily users. Here, I've highlighted in yellow points of iBobber use across the globe since the device's launch in 2014. As you can see, it's used primarily in the US, Europe, and China. Today, I'll be describing my work on the continental United States subset of this data, for the years 2017 to 2018. For our methods, we first linked iBobber use to lakes. Then we calculated the shortest road distance traveled between all of the lakes that a single user had visited and the days between their visits to different lakes. Lastly, we overlaid invasive species distributions to identify invaded lakes and examined the attributes of fished lakes compared to all other lakes. As you can see on this map, where red indicates high iBobber activity and blue indicates low, fished lakes are typically urban. Here we see hotspots at large cities across the US, such as San Francisco, Denver, Dallas, Miami, and New York. We also found that the mean surface area of fished lakes was much larger than that of all lakes across the country. Lastly, we found that fished lakes were 10 times more likely to be reservoirs. And this is important because previous studies have shown that reservoirs are more likely to contain aquatic invasive species than natural lakes. In this plot, we show the number of days between trips by the same iBobber user at different water bodies on the x-axis, and the percentage of all between lake movements on the y-axis. As you can see, more than 50% of angler movement between lakes happens over a time frame of 2 days or less. This is important because even though most movement occurs over a really short amount of time, many aquatic invasive species can survive beyond 2 days when exposed to drying and overland transport. Above, we show 6 prevalent invasive species and the percentage of iBobber between lake movements that occurred within the number of days they can survive drying, indicated by the dashed red lines within the plot itself. Some species, like hydrilla on the far left, can survive less than a day, but others, such as Chinese mystery snail on the far right, can survive up to 63 days. To further demonstrate that angler movement poses a high risk of invasion to new water bodies, we routed road movements between a handful of lakes with and without invasive species present in Wisconsin. Here, blue lines connect an invaded lake to another invaded lake, and red lines connect invaded lakes to lakes without known invasive species presence. Given the risk that angler movement poses for introducing new invasives to new water bodies, we were interested in developing a broader angler movement network in the next study that I'm going to discuss. So given the role that humans play in relocating aquatic invasive species across a pretty wide landscape within the continental US, it's important that we understand human movement between lakes to inform the implementation of preventative measures such as signage, watercraft inspection stations, and boat cleaning services. But a persisting challenge to resource managers is tracing human movement across broad spatiotemporal scales. So here we asked if social media can help us understand the geography of angler movement by building a large-scale angler movement network for the Western US. We did so using data from Fricke, which I described previously. Here, I've simply shown the spatial distribution of the more than 230,000 Fricke posts occurring on lakes in the Western US since the service's launch in 2005 up until 2018, which is the time frame that we worked with for this study. You'll note that gaps with relatively few posts across the landscape generally correspond to more arid regions of the Western US with a lower density of lakes to begin with. If we look at the within-year distribution of trips with months on the x-axis and frequency of visitation on the y-axis, we see that visitation peaks in the summer months when weather and accessibility on lakes tends to be more favorable. When we flip to an interannual perspective and replace the x-axis with years, the story gets a little interesting. Fricke use actually peaked in 2010 and has been on a steady decline since. And this is likely because Instagram, which is a more popular social media platform, launched in 2010. We constructed our network using the more than 56,000 trips by Fricke users who visited multiple water bodies during the time frame of this study. These individuals visited more than 9,600 water bodies. And as you can see in this map of the water bodies, Visited water bodies tend to be near urban centers such as Salt Lake City, San Francisco, Seattle. This histogram in the lower right corner shows the proportion of Flickr users on the y-axis by the number of water bodies each individual user visited on the x-axis. You'll note here that more than 50% of users only visited 2 water bodies, which means they're only contributing 1 connection to our very large network. If we look at the distribution of road distance between visited water bodies, we also see that the median distance moved was pretty low and was only 32.3 kilometers. So for this study, we considered water bodies connected by Flickr user movement from one lake to another and separated by a road distance of less than the median 32.3 kilometers to be connected. Before we dive into our big network model for the whole Western US, I wanted to show you a simplified network structure. You can think of the circles as lakes and the lines as Flickr user movement between them. Some lakes will be connected to lots of other lakes, whereas others will only be connected to 1 or 2. This is likely a consequence of both lake and road geography and Flickr user movement patterns. So here we have our whole user movement network with all 9,600 plus lakes. Each individual circle is a lake, and clustered circles of the same color are distinct connected subnetworks within the larger Western US network. You can disregard the specific colors here. They're simply meant to distinguish subnetworks from one another. I'll say more on what the different circle sizes mean in a minute, but for now, just know that larger circles indicate lakes that are more connected to other lakes through Flickr user movement. As evidenced by the fact that there are 682 distinct subnetworks, this network as a whole is highly fragmented, with many subnetworks of only a few connected lakes. In this subnetwork analysis in the lower left-hand corner, with subnetwork or component on the x-axis and the number of lakes on the y-axis, we see that there are 10 subnetworks with more than 100 lakes, which means that even though this network is fragmented, there are some really large connected subnetworks across the Western US. To offer an example of some of the most useful metrics we can use to classify lakes within a network, here I've pulled out a single subnetwork that spans the state of Utah. This subnetwork has 3 particularly dense clusters of lakes connected by Flickr user movement, which are centered around Great Salt Lake, Lake Utah, which is a popular lake for fishing outside of Salt Lake City, and Blanca Lake, which is a lake on the east side of the state in the Wasatch Mountains. Notably, this subnetwork extends as far south as Lake Powell Reservoir, which is on the state's southern border with Arizona. The first metric we're interested in is centrality, which tells us how important a water body is within the network based on the frequency of visitation and connectedness to other lakes. I like to think of lakes with high centrality as the center of a bike wheel with many spokes radiating outward, connecting the central lake to lots of other lakes. This subnetwork has a relatively high average centrality of 16, whereas the fragmentation of the whole Western US network is reflected in its relatively low centrality of less than 1. The second metric of interest to us is betweenness, which is a measure of the extent to which a lake lies on paths between centralized lakes. So for example, these 2 lakes that connect Lake Utah with Great Salt Lake have high betweenness because they're connecting 2 dense clusters of lakes. The average betweenness for this subnetwork is a little bit lower than the whole Western US because any of these spurs that only connect to one water body are going to have low betweenness, and this subnetwork as a whole is quite clustered. These network metrics are particularly useful from a management perspective because they allow us to identify lakes that are management priorities based on their location. Here, I've zoomed in on the Utah network to look at 2 lakes that serve really distinct roles. Utah Lake has a high centrality relative to the whole subnetwork, and you'll note the spokes on a wheel pattern that I described earlier. whereas Deer Creek Reservoir at the southern end of the Wasatch Range has a high betweenness because it's connecting two different clusters of lakes. Through a management lens, lakes like Utah Lake with high centrality, especially those which we know contain invasive species, are great places for required boat and gear cleanings to prevent distribution of aquatic hitchhikers among lakes within this broader cluster. On the other hand, water bodies like Deer Creek Reservoir that serve as bridges between clusters are prime locations for watercraft and gear inspection stations to intercept the flow of invasive species from one lake cluster into another. So if you've pulled anything from this talk, I hope it's a recognition that social media is a vast, largely underutilized source of outdoor recreation data that has the potential to inform how and where we allocate resources to tackle really large-scale conservation challenges, such as the spread of aquatic invasive species. Some of our next steps include adding additional social media data sources to our network models and acquiring better invasive species distribution data from state and local governments. We'd also like to incorporate text and image analysis into our social media lake visitation models. Right now, all we're estimating is total visitation per lake, which doesn't tell us much about the specific activities people are engaging in. Long-term, we'd really like to look at the cultural ecosystem services that people associate with lakes, which could include specific activities like fishing for sustenance or fishing for recreation, boating, spiritual appreciation of lakes, and through image and text recognition, as shown in this picture, we can identify objects like boats and fishing gear that allow us to infer the specific type of lake-based activities that people are participating in when they are on lakes. Some challenges with social media data include that smartphone ownership varies by age, education, and household income, and a relatively small number of social media users are actually consistent in using the platforms that they have accounts on. This 2021 figure from Pew Research Center shows the percentage of US adults who say they ever use each of these indicated social media applications. As you can see, even though social media use is going up, it's still less than half the total adult population. But similar limitations in estimating the activity of an entire population with only a subset of that population's data apply to in-person surveys as well. Working in this space is also really challenging because access to platforms is ever-changing and somewhat turbulent. For example, in 2019, Flickr limited the number of photos that can be stored in free accounts, which eliminated a huge amount of data that had previously existed on the platform. In addition, Instagram was bought out by Facebook, which led to the elimination of the Instagram API that used to exist and allowed researchers to pull Instagram data for these purposes of estimating visitation. Lastly, I'm sure we've all heard about the current turmoil going on at Twitter. It's really unclear at this point what that platform's future is going to look like and if there will be continuing researcher access to the Twitter API. In closing, I think there are some really great opportunities within this space to encourage collaboration between tech companies and between resource managers. First and foremost, some app companies are really great about sharing their data, but not all. For example, we reached out to Gaia GPS independently, and they were nice enough to share our data, share their data with us for this study. But on the flip side, we run into other social media companies that are really opposed to sharing their data or will only share it with specific researchers working on very specific and sometimes kind of more lucrative opportunities. In addition, I think intentional construction of recreation-based applications to partner with resource managers and emergency managers could be really fruitful moving forward. I think especially in an emergency management context, we think about all of these geo-tracking apps that exist, like Strava or Gaia GPS. And right now, those activities don't really link to broader response systems. So I think there's a lot of opportunity there to co-develop applications and actually intrinsically link them into our governing systems. instead of researchers having to come from behind and try to work with the data that's made available to us. So in closing, I'd like to thank our partners at King County Water and Land Resources Division and the Snohomish County Department of Conservation and Natural Resources for providing the on-site lake visitation data that I talked about in this study, as well as the hundreds of community volunteers who collected that data. I'd also like to thank my co-authors, Julian Olden, my advisor, and Spencer Wood for all of their help on this work. Thanks for listening, and I'll gladly take any questions that folks have.
Let's see if Jim can unmute himself. Hello. Thank you, Rachel, for a great talk. We'll give you a couple minutes to recoup as we give away some prizes. For those of you who don't know, we try to give away Grit City Think and Drink swag. So let's see if you can see it next to my face. They're socks. So Grit City socks, we are almost out of these. So these are limited edition. I do apologize. We're only down to one size. So if you win, you get this size. So that's hopefully you can find somebody that they fit, if not you. So we're gonna give away a couple pairs of those socks. And I do very little research to come up with some trivia questions loosely related to the talk that you just heard. So anything that's incorrect in this is totally on me, and it's my own sense of these things being connected that determines what questions I ask. So you're gonna chat your answer to me, so make sure you get your itchy chat finger going, and I will give the socks to the first person to get close enough to the answer. Okay, get ready. The first question I have, and Rachel almost gave it away, but the question is, of all US people, not just adults, what's the percentage of people in the US right today that use social media, some form of social media? So what percentage of all US people use social media? Nicole says 37%. Others? 75 from Utah. Everybody else is trying to figure out what social media is. 57. Cool. Well, we're going to give it to Utah. She's very close. It's about 72% right now by the Pew Research Center, says that 72% of all US people are actually using social media of some sort. It doesn't actually say how many they're using, because some of them are using multiple, as Rachel pointed out. So 72% of US. And it turns out, I looked this up as well, in the world, it's just over 50%. So it's about 4.4 billion people in the world are using social media of some sort. I have no idea how they actually got that number, but I'll have to look into it for future things. So Utah, I will get you your pair of socks. So second question, get ready. The second question is, how much time each day does the person who uses social media, how much time per day does each person use social media on average? How much time per day does the person in the US use social media? Nicole says 5 hours, Utah 6. Keep them coming, folks. 23 hours. Wow, Tom, you got a problem. Anybody else? Got 4 from Jill. Going once, going twice. Jill is closest. On average, it's just over 2 hours per day that the people who use social media use it. That doesn't mean that there aren't some people that are using it 23 hours a day. But luckily, the average is still down around 2 hours. So yeah, that's what they report. I'm not sure how they collect the data, Nicole, so it's a good question. But Jill, if you could chat to me, because nobody else can see it, if you can chat to me your mailing address, I will get you your pair of socks. Thank you all for playing. Thanks for coming tonight. And now we are going to, oh, and I should just put in one last plug. Remember that the next talk is January 10th. And we're going to talk about self-care in the time of COVID. So hopefully you guys got some questions for our speaker. I think I saw some already in. So if you have your questions for your speaker, go ahead and chat those in here. And Rachel, if you're ready, the first question is, To what degree might an intervention like an inspection station lead users to change their behavior, i.e. Visit a different lake for angling and then change the shape of the networks?
Oh yeah, totally. I can provide a really anecdotal answer for this. And I think my dad's on this call, so he'll really appreciate me sharing this. But turns out a lot of boaters actively try to avoid inspection stations when they're driving too. So that just further changes the network. But yeah, I think inspection stations can change the shape of the network when they're on major highways and when enough users are actively trying to avoid them that they reroute their movements. But generally, we only put inspection stations on major highways to begin with, not on like more minor highways that are interstate. So I doubt it would change the shape of the network that much, because ultimately those inspection stations are typically catching people who, are driving through multiple states on a longer distance trip than just like, bopping to the next state over.
Cool. I had a question for you while other people figure out what they're going to ask. You talked about the model that you have and how multiple social medias make a better model. So can you explain how those interact? So how Flickr and Gaia interact in your model?
Yeah, totally. So most social media like correlates with each other in terms of like there are sites that have a lot of social media activity and there are sites with lower social media activity. For context, in our model, that's like Green Lake is kind of the hotspot of social media activity, which makes a lot of sense, right? It's like in the middle of Seattle. Whereas like there are smaller lakes on the fringes of King and Snohomish County that, don't have a huge amount of access or maybe only have like a single public boat launch. And like across the board, those lakes are not going to have a ton of visitation. But interestingly, and this is kind of why eBird was different from all the rest of them, is that there are a few lakes that there's a bunch of eBird activity on for whatever reason, and like no other social media data. Yeah, so generally kind of those four social media platforms that were similar to each other, it's a Flickr, Gaia, iNaturalist, Twitter. Those are all pretty similar to each other in terms of distribution. And then eBird's the outlier at the end of the day. Yeah. So that's like I said, that's why like Twitter and Gaia always occurred together in those models, is because they're really strongly co-correlated with each other. And that's just that's something we try to avoid sometimes in science, right? But like, that's just a sort of general fact of working with multiple social media platforms, is that they're generally going to co-correlate.
Mm-hmm. And another question, you mentioned something about potentially, and this is something I'm very interested in, is trying to figure out who is actually recreating in such a way that it could potentially be a public health concern if you've got a contaminated lake of some sort. And I was wondering how, you mentioned something about people fishing for subsistence. How do you get that out of an image?
I don't think you get it out of an image. Unfortunately, you can get fishing out of an image, but that's where I think text analysis is really helpful, right? If somebody's like, oh, just caught this fish, excited to go home and eat it, right? Then you can do that, text-based analysis of, okay, like they are, expressing an indication to consume this fish that they've just caught.
Gotcha. That's cool. Another question, you introduced your study with an important question about use of social media and smartphones affecting outdoor recreation, that it's a double-edged sword. Do you think that on balance, social media and smartphones are good or bad for outdoor recreation management?
Well, that's a really difficult question. Thanks for asking that. I don't know. I think I agree with the double-edged sword analogy that I personally often go outside to try to get away from social media, but at the same time, I'm still active in many of these online communities where we're all sharing the places that we're going skiing or going hiking or going backpacking, right? And I do think it's hard because as a user, I kind of appreciate both sides of it, right? In that, like, it's nice to go get away from that, but you do sort of have to work a little harder these days to try to find spaces outside if your whole goal is to get away from people and get away from society. Yeah, I think it's, for better or for worse, that I'm of the mind that it's like the world we live in, and so we might as well try to use this data for good instead of just letting these companies, use this data to, send targeted ads to us all the time.
Mm-hmm. Yeah, I could definitely see where, you know, it being protected, because there's a lot of people that have their secret spot, right? Whether it's for fishing or it's for crayfishing. I know that crowd definitely can be very protective of where they find their crayfish, or people who go mushroom hunting. And so you could see where if there was somehow to like mine social media for finding that information, you wonder, you know, that would be a whole different thing. I think it would change how people use social media. I think at that point, if they knew that somebody could use that information to find out where to find their secret spot.
Yeah.
Other questions, folks? Anybody? Well, I think everybody's done for tonight. Thank you very much, Rachel. Thank you all for coming. Thank you for an awesome talk. I'm looking forward to what you're doing with your next round of research. And hopefully we'll see everybody in January. If not, everybody have a great holiday. Be safe, and remember to share your social media posts that Rachel has some things to actually use in her research in future years. All right, everybody take care. Have an awesome time. Thank you, Rachel, for a wonderful talk.
Thanks, Jim. Thanks, everyone.
Bye, folks. Good night.